In this video, we will apply what we've learned about algorithms to the subject of exponentiation. The following is the naive exponentiation algorithm, which accepts as input an integer b and a non-negative integer n, and returns the value b to the nth power. Let's run this algorithm with the inputs b equals 2 and n equals 5. The first step in this algorithm is the conditional statement if n is equal to 0, then return 1. Our input value for n is not 0, so we skip step 1 and proceed. Next, we create the variable c and assign it the value of 1, and create the variable I and assign it the value 0. In step 4, we have a repeat statement, which signifies that we are entering a loop. The first step of the loop is to redefine the variable c to take on the value c times b. The current value of c is 1, and the current value of b is 2, so after reassignment, the variable c will take on the value 1 times 2, which is 2. The second step of the loop is to redefine the variable I to take on the value I plus 1. The current value of I is 0, so after reassignment, the variable I will take on the value 0 plus 1, which is 1. Next, we reach the stopping condition until I is equal to n. Before we proceed, we need to make sure that this condition is satisfied. Otherwise, we will have to repeat the loop. The current value of I is 1, and the current value of n is 5. 1 is not equal to 5, so we need to go back and repeat steps 4a and 4b again. This loop must be repeated an additional 4 times. For the sake of time, here is our work for the second, third, fourth, and fifth iterations of the loop. After the fifth iteration of the loop, the value of c is 32, and the value of I is 5. So we check the stopping condition until I is equal to n. 5 is equal to 5, so we do not need to repeat the loop, and we can proceed to step 6, which is to return the value of c, which is currently 32. So, for the inputs b equals 2 and n equals 5, the algorithm returns the value of 32, which is 2 to the 5th power. Try running this algorithm again with the inputs b equals 3 and n equals 4. Be sure to track each variable and their values carefully. For the inputs b equals 3 and n equals 4, this algorithm returns the value c equals 81, which is 3 to the 4th power.